when we were thinking about moving forward with Globe and hearing about the deepening the connections between SMAP, well, actually NASA active missions and Globe protocols, I kind of had this like throwback thought of like, well, we did this, and maybe it's worth bringing forward again, talking about what we did, so we can kind of refocus on the future, so thinking about our success from the past and taking it into the future. So Brian and I did a lot of work together for a lot of years, so I figured it's worth sharing. Goals for the session today really is just that, thinking about that connection again from NASA missions to Globe protocols. We're going to share some research that we did with undergraduate students at Bowling Green State University over a course of 4 years. And then at the end of the presentation, we'd really like just to have a conversation about what you've done related to SMAP or to NASA active missions. And if you haven't done anything yet, let's just talk about what we might do in the future and where this could take us. So I'm going to have Brian talk about the SMAP mission and then a little bit about a news story, and then I'll come back and talk about the research that we did.
All right. Thank you, Jodi. So yeah, so this, of course, began when SMAP was launched. And you might also remember that we had a campaign for 1 year around, 2015 into part of 2016 called I think it was the Globe Soil Moisture Measurement Field Campaign. I think that was the name of it. There's been a bunch of campaigns that I led with a bunch of my colleagues that Jodi and a lot of her students were part of with Bowling Green State University. And we had lots of speakers from, a lot of them were from Jet Propulsion Laboratory, where, which was basically the SMAP mission was a NASA mission, but it was, there were two instruments on board, where it was part was the NASA Goddard Space Flight Center, and part was the Jet Propulsion Laboratory in Pasadena, California. But yeah, so as you can see here on this slide, the satellite, the SMAP mission, the satellite was launched on the 31st of January 2015 from the Vandenberg Air Force Base. Now it's the Vandenberg Space Force Base. And when it was launched, it has basically its goal is to measure soil moisture every 2 to 3 days. So you're getting a global map of soil moisture every 2 to 3 days. And it's still in space right now, and it's taking great measurements, right? So, but that didn't happen right away. So on board, we had two, as I mentioned, two instruments. There is the passive radiometer, which measures the ambient energy coming from the soil, from Earth, from the soil, from the ground. And then you have the active radar, which is sending that active signal from the satellite. It's penetrating the ground down, 2 inches, 5 centimeters. That active radar signal is scattering, and then it's returning back to the satellite. And we're getting basically a combined 9-kilometer combined resolution. You're getting about 36 to 40 kilometer spatial resolution with the passive radiometer. And we're getting about a 3-kilometer spatial resolution for the radar. The problem is that around July of 2015, the radar failed, and it was due to what's called a high power amplifier. Basically, it was not transmitting data. We're like, crap, we're not getting the data back that we needed, so we're just getting the passive radiometer. So what do we do? So what happened is that the teams got together at Goddard and, well, basically all of NASA, really trying to figure out what we wanted to do. So we started talking to our friends at the European Space Agency, and we realized that the Sentinel-1 satellite flew, very close to the SMAP satellite, in that track, in that orbit path. And we started using that signal, using that active radar. So what we did is we realized that when we combined that active radar from Sentinel-1 and combined that with the passive radiometer on SMAP, we actually got a better, combined resolution of 3 kilometers and sometimes down to 1 kilometer resolution. So we're getting really, really high accuracy, high resolution combined data, for the SMAP satellite combined with the Sentinel-1. So we're still getting amazing data back. The first 3 years, I think we got about something like close to 150 to 175 terabytes of data, of soil moisture data. We're getting this global coverage every 2 to 3 days. So that is a lot of data to be able to compare to that ground-based data that Jodi and her students did, and the folks from around the globe community did, using this the original SMAP block pattern soil moisture protocol, which is measuring this gravimetric the volumetric soil moisture measurement. So that's kind of SMAP in a nutshell. You have this rotating antenna that's creating this huge, this wide swath. You have this six meter antenna rotating, creating this wide swath in the earth where we're getting this soil moisture measurement back. And next, please.
Yeah, and before Brian goes on, just listening to what Brian just said reminds me of why this is such an important partnership and collaboration. Because as a Globe leader, partner, and educator working with Bowling Green students, I didn't have all that background on SMAP. I could read it a little bit, but by having Brian in the room with us as we're doing this research, you can see how it elevated the degree of depth of knowledge our students learned in their skill base and everything else. So I so appreciate Brian's expertise there, and you could see that just from his presentation about SMAP.
And what we did was, since 2025 was 10 years of SMAP in space, and basically 10 years of the SMAP Globe collaboration, when we released the SMAP block pattern protocol, the measurement protocol. We wanted to do something, to get out there. We have this protocol out for 10 years. SMAP's been taking space-based observations of soil moisture for 10 years. What has been done? Of course I saw Marilay's on here. Of course, we didn't get as many observations as clouds, with the tree height that I work on a lot now with the ICESat-2 mission, which is great for what we're talking about, how we compare the tree height observations to ICESat-2 and the JEDI mission, how we compare land cover to Landsat stuff, with NASA. But we didn't get as much, of course, with the SMAP block pattern. But the protocol, it's a good protocol, but it's a lot more involved, a lot more equipment needed. Soil drying oven. You'll see the bucket method that Jodi was using. Heat lamps. Some folks are using as well. And the soil can. So a little bit more involved with taking observations. But what we wanted to do was create, an article, that some type of news article where it would highlight, some of the things that we've done since we did this. We've been doing this for 10 years, and there's a link there where we created a tiny URL because, the Globe one on the URL for the news article is very long, so I didn't want to include that whole thing. But when you at your leisure, take a look at that. It's SMAP, and the Globe program celebrate 10 years of measuring Earth's soil moisture. And on there, you'll see, a synopsis of what Jodi and her students did at Bowling Green State University. You'll also see what person you may know, Jeff Bauman at Shoemate Middle School. You'll see what he did with his students as well. He created basically a SMAP lab in his classroom, in 2016, 2015, 2016, I think up to around 2018, he did a lot of that. And there's some quotes from some students in there as well, and some maps to show you, especially with Bowling Green. I think Jodi shows you some of that too with the slides as well. On here, but it goes through, showcasing, what Jodi and Jeff did, in the classrooms from that middle school level all the way up to the university level, showing you that this is accessible, that the Globe, the data is accessible, and that the NASA science, the data is accessible for all those different age groups, that there's not necessarily a barrier for that data, that it's all accessible to be able to compare that ground-based data that they were collecting with that satellite data that was coming in fast and furious, and is still coming in fast and furious. So take a look at that article when you get a chance. And with that, I'll pass it back to you, Jodi.
Thanks, Brian. Okay, so I'll tell you a little bit about what we were doing at Bowling Green. There was some money that came to us from the Choose Ohio First grant, and we created a program called BGSU Action, and it really was science and math education in action. And the big idea was to prepare research-ready teachers. And the way we did this is we started with the Summer Bridge program to teach the kids how to get ready for being university students. Within that summer course, they asked me to teach a little micro course, 2 weeks, and to teach kids how to do research. So, of course, I brought Globe in, and it was a Globe course, really, is what we did for 2 weeks. And we used surface temperature because it's just a great way to collect good data quickly and have the students be able to report out on something, within a 2 week period of time. So we did that every year of this program. And this program went on for about 10 years. I'm going to talk about the 4 years that we did soil moisture. In year one, after the kids started their first academic year, they were assigned, or they actually selected a mentor to work with. And then we took on a year-long STEM research project with them. And that's where this SMAP soil moisture research came from, that first year experience. Just so you know what happened after that, in year two, they did a STEM business internship to learn how math and science were used in industry. Year three, they found another mentor, and I worked in that year too, and we created an action research project that dealt with something in the classroom like collaborative learning or hands-on research. And some of my students wanted to know, do students prefer to learn in a field-based environment, like using Globe in the classroom, and what the effect that had on student confidence and self-efficacy and even learning and deepening their learning. And then in year four, they actually enacted those action research projects. So it was a 4-year project. And so all the projects, all the students that you're going to see in this presentation, they're all math and science teachers today, which is kind of cool. They're all out there doing it today. So the years that we ran this collaboration was 2015 to 2018. And I found Brian getting ready for this presentation on August 19th of 2015. I wrote to Brian and said, hey, do you want to collaborate on this? I need some help. And he said yes. And we met via Skype. That's kind of the timing of this all. We were Skyping it back then. In the first year, because we needed to plan the project and everything else, I had the kids for the whole year. But knowing that fall is data collection time, and then spring is kind of like dissecting the data, doing some background research, putting the presentation together, and then delivering the presentation. So the first year, we only got 8 weeks of data collection, 1 day a week. And that's because we were building the project. Thereafter, we were really able to collect data all semester long, all fall semester. And then we got better at getting the kids to collect data during free time in their schedule so that we can line it up with flyovers. And that took us a little while. The first year, we didn't even think about that. Second year, we tried. I had them 2 days a week, and if it fell on a flyover, we did it. The third year, we actually figured out how to get flyover days to line up with data collection days. And then on the last year, we got that all together. And then the students were into drones. And so we also threw some drone work into that. So you're going to see the actual student presentations. And I'm not going to present every slide of their presentation, but I want you to get the feel for what this looked like and what they got out of it and how this might, again, lead us into the future. So this is a group of students that I worked with, 6 students in 2015. You probably don't remember this, but those students came with me to the Denver Globe annual meeting, and they presented this research there. And really, they were looking at soil moisture from within and above Bowling Green State University. So again, thinking about the data collection we can do from the ground, and then the SMAP satellite data. So I told you in the fall, we collected the data, but in the winter months, we actually dug deeper. So they were looking at, well, why soil moisture? What is SMAP? They were doing all that background research. And Brian was, worked with us throughout the whole year. So whenever we needed him, he'd come in and Skype or Zoom in with us and help us just really deepen our knowledge. Every year, the students took on some research questions. Some of those were related to SMAP, and how our data, our local data, align to the satellite data. And you see that as research question number 3. But there was also some other sub-questions that they were interested in. And I wanted to make sure there was enough to do for 6 students to keep them busy and learning and so forth. So this year, we also looked at how the soil moisture differed across 9 testing sites. And we looked at that soil drying methods, the bucket method versus the oven method, knowing that most schools can't afford the $200+ oven, but they could get a bucket and a heat lamp. So, I think maybe, hopefully you do know the soil moisture protocol, but these are the materials that we used along the way. And The methods, again, I'm not going to go through all of that, but we were looking at gravimetric and volumetric. So we used that soil can that you saw on the last slide, pounded it into the ground, right? Pulled up that amount of soil, and that matches the satellite, that active radar that Brian was talking about, that 5 centimeters, that's a 5 centimeter can. So that was a really important part of what we did, making sure that we were holding true to the GLOBE protocols to make sure our data then could really be compared to the satellite data. The results, I'm going to really focus on the connection with the satellites, but these are the 9 sites, and they did find out that, yeah, irrigated land is wetter than dry land or non-irrigated land. And the golf course was an old golf course that no longer was being irrigated. So that was kind of cool that they saw that, and they made a recommendation to the university that, well, why are we putting so much water down on the irrigated lands when maybe we should be cutting back a little bit because everything else seems to be looking just fine. They also looked at this oven method versus the bucket method, and they ran some statistics on this and found out that there really was no difference between how we dried the soil. They were really very similar. So it looked like both of those mechanisms worked fine. And we reported that back to Brian so that he could share that with other schools, right? That, the bucket method was working just fine. And then this was their first graph. Remember, this was 8 weeks of data collection, and we did not always line up with flyover days. And so those are the 8 days of our data collection. Actually 7. I think one week we lost the data. And 3 of the 7 dates did not line up with a SMAP flyover. But you can see the relationship between our data and the SMAP data. And we had to work with Brian and Erica, the lead scientist at the time. I think she was the lead scientist, to get those actual numbers, right? Because otherwise we're just getting a color code from the visualization of the satellite data. So we actually had to work to actually get some values of what the satellite was detecting for our grid, our 30 kilometer or 3 kilometer. I think this is at the point as it was 30 kilometers for this year. Okay, and this is just another way of looking at it, but one of the things we realized is that the BGSU data was consistently higher than the SMAP data. Again, we're looking at local data. SMAP is a much bigger square, right, that it's looking at. But my students wanted to see if that was similar to other schools. So they looked at Croatia. They actually looked at Shoemate Middle with Jeff Bowman. They looked at University of Toledo data. And we were starting to see this pattern that the GLOBE data seemed to be a little bit higher than SMAP data. And I don't know if that was because it was early on in SMAP when they were still trying to figure out that issue with the active radar or what was happening, but it was a pattern that my students did notice. And this was a really fun part for my students, is when they were able to start looking at visualizations. And, so they looked at the satellite data, and then they looked at the GLOBE data. They looked at the legends at the bottom, and they thought it was really cool that the colors matched, so at this point here is where Bowling Green is. And that the little dot on the GLOBE visualization was actually the same color of the square on the SMAP visualization. And they thought that was really cool, that they were able to start really looking at comparing the data with not only New Berkeley, but also with the visualizations. Lots of conclusions, but really I wanted to say that they found out that our data, those 7 dates, were 4% higher than what we saw from the NASA SMAP satellite. And one data point accounted for almost all the variance. So they were really starting to look at the data at a much deeper level. And that was really important to me, because as a university professor, you never know how these student research projects are going to go. Are they going to get in enough depth, right, of knowledge? And this certainly gave us a lot to look at. Talking to Brian, trying to figure things out, trying to go a little bit deeper and figuring out what it meant. It was really, really nice. And then they just suggested some next steps for where we should go for the next year. And so they handed it off to and you can see they had references, but the first year we only had 4 references. We're starting to get into this, but you'll see year by year, we're getting into it deeper and deeper. And I thought that was really great, a good way to just really learn from each other and then deepen our knowledge. 2016, we figured out a way to go all 14 weeks. And so now we're collecting data, and all throughout the whole semester, much more data to look at. And we use some of the next step suggestions from the year before. We still wanted to compare our data to the NASA satellite data. This group wanted to start to look at, well, why are we having different soil moistures? Let's look at soil temperature and surface temperature as well to see if we can start to make some sense of this. And they also wanted to look at cloud cover. So again, I skipped most of the other slides for this group, but here's what you see. Now we see a whole semester worth of data. The orange is the Bowling Green data. The black is the NASA data. They ran some statistics on this, and they found out that there was this correlation of 0.75, so a strong correlation between the two sets of data. What I think is really interesting is that they started talking about this, my students, the 17% threshold, that as soon as you get above 17% soil moisture, then the data seem to really line up well. So they're like, well, what's happening under 17%? So they kept, coming back to this. Well, what's going on under 17%? Up above 17%, everything is really tight and nice. What's happening below that? And I thought that was great because, again, we're looking at local data for us and this much bigger regional data for the satellite, but they're still noticing these patterns and they wanted to know more and deepen their knowledge of what was going on with that. They also then looked at 2015 versus 2016 data. And again, 16, we have more data because we worked the whole semester. But they found out that 2016 was a wetter year, and they're starting to ask questions and think about that. Then these are their graphs, okay? So it's a little busy, but that's okay. They wanted to think about, well, why is soil moisture, what's driving this change in soil moisture? So they started to look at surface temperature and soil temperature, and they realized that there's this really strong negative correlation, 0.96, negative 0.96, between soil surface temperature and soil moisture. So they kept saying that's what's driving it. As the earth is heating up and the soil surface temperature is warming, it's driving the water out of the soil. So I thought that was, again, another good way to look at it. And through the conversations with Brian and his team, they started asking deeper questions. They wanted to know what was going on with it. And again, as a professor, I really appreciated that. Then this is their data looking at the cloud cover, and they did see a pattern there again, a strong correlation of 0.78. As we had more cloud cover, we had higher soil moisture. Makes some sense. That was the end of their presentation. Then we got into 2017. And this group, again, I had 6 students, and they took on really the same questions. They're all out there teaching right now. I love seeing their smiling faces because I know they're out doing good things. But again, really the same 3 questions. They just wanted to go at it deeper and look at it again over 3 years. So this is now 2017 data, and we're collecting data more days per week now. So you can see more points as we go year to year. And we still have that really high correlation of 0.625 between the BG and the NASA data. And again, our BG data shows more extremes. That would make sense. It's local. It's not regional data, right? So we can see these extremes, these peaks, a much bigger slope than you see with the NASA data. Then you see the 2015, 16, and 17 data. They just wanted to compare what was happening year by year. And we're getting more soil moisture. Again, that's just 3 years, but it was statistically, they found out those years were definitely different from each other. We're getting more precipitation, more soil moisture each year. And they kept coming back to surface temperature, probably because we did surface temperature in the summer every year with the kids. They kept saying, I think it's the surface temperature driving the whole thing. So they really wanted to look at this. So we collected surface temperature data throughout the whole semester. And then they looked at the relationship between soil moisture and surface temperature, saw this really nice negative correlation. And they kept saying, it's the driver. So, surface temperature is the driver for this. They were looking at clouds again. And this group really said they thought there's a slight correlation with cloud cover. But what they noticed is that when we had high cloud cover, then we had consecutive days of high soil moisture. So there was this holding pattern. The soil, the sponge, the soil is the sponge, was holding on to some of that moisture after those cloudy days. So again, as a perspective that they came up with, I never even thought of it, but they started looking at the data in a deeper way. Relative humidity was a small factor. I'm just going to fly over that. But look at the references now. All of a sudden, they're getting into this. I'm learning more. Brian's teaching us more. His team's teaching us more. They're going deeper. And I appreciated that very much to start to see them pull together some better data from this. This group really wanted to think about climate change. They kept talking about climate change. I said, well, we only have 3 or 4 years worth of data. They're like, yeah, but let's look at, what the predictions are. In one of their classes, they learned about the NOAA state climate summaries. So we pulled the summaries back out and we started looking at what were the projections for Ohio. And we looked at the high emission scenario and the low emission scenario. And what they concluded after reading this document is that for Ohio, we are expected to get hotter, wetter in the fall, winter, and spring, and drier summers. That's what this NOAA report told them. So when they started looking at it, Ohio by the end of the century looks more like Texas, and that there's going to be more extreme rain events, and that drought in the summer, the dry months for Ohio, is going to get more drought, right? So they wanted to start with this and then use globe protocols and the soil moisture protocols to check that out. And they also wanted to look at drones, right? So for some reason, one of my students in this group is just really into drones, never flew a drone, wanted a drone, kept talking about drones. So I found the gentleman in the maroon sweatshirt was my neighbor, and I knew him when he was 2 years old, and he grew up to be a drone pilot, got his certificate. So he brought his drone out for us and helped us do this drone work. We used the same materials, except this time we used a Phantom drone and then the drone deploy software, which I learned about in a Globe meeting somewhere. One of the meetings we were at, I think in Chicago or somewhere, someone was talking about it. I'm like, okay, we're going to try it. So same methods that we used the years before, but this time we flew a drone over a Maumee floodplain. Couldn't fly in Bowling Green because we have an airport there. So we went to my hometown. And then we also took some soil samples. So we had the satellite stuff going on, and then we had a drone fly over, and then we actually took some soil samples, and we wanted to see what we could see with the drone. Okay, and then of course all of the data was submitted. So over the course of the semester, again, there's the alignment. This is actually, they decided to take all the data from 2015 to 2018, plotted on a graph. Again, the orange data is the data we collected from the field, and the blue data is the NASA SMAP satellite data. And there's that nice correlation. You can see when Brian was talking about some problems early on with that, you can almost see it right on that map. Then all of a sudden we get a lot of data that's very closely aligned as we move along. I'm just going to skip over some of this. I want to talk about drones, and then we'll open it up for conversation. So these drones, this is the Google Earth image of this Maumee floodplain. It's butts right up to the Maumee River. And that was taken in April of 2018. And then we flew the drone over on April 3rd of 2019. And you see that in the top right image. And then we used this drone deploy software to look at a plant health map of that same area. And you can see that healthier plants are in the red. You also see that this red up here is a school building with a roof. So that's not a plant. But everything else, all this other border stuff is really kind of plant life, and all these hues down in here. And so you see some reds and some greens of some plant life. And then you also see an elevation map. So we used all 4 of those maps to see if we can make some sense out of our data. And then we collected data at these 7 points throughout this, from this school all the way down to the river. And you can see that our values of our volumetric soil moisture data are there. And it worked out great. Really, what we found out is that you could look at this soil health or this plant health map from the drone and make some predictions of where you find soil moisture. Makes sense, because really plant health is related to how much water those plants have in them, which means the soil would have some water in it. So we thought this number 3 was really interesting, because we didn't know what was there at first. We flew the drone over and we were like, oh, what's going on here? And the same thing happens with the elevation map. It's a little lower here. Red is high elevation, purple is low elevation. So there's something going on right here. So we went and collected a sample from there, and sure enough, that was definitely almost double as much soil moisture than in the other places. It was just a really marshy area. we could see it. We could see it from a drone before we ever took the soil sample. So that was really kind of cool. And the girls all got to fly. My team this year was all girls. They all got to fly a drone and they were very happy about it. And you can see again, they just went deeper and deeper and deeper with their research along the way. So good. I left us some time, 13 minutes to have a conversation. Brian, first of all, if you wanted to say anything about that, any of those slides or any of that research, this would be a time to do it. And then we can open it up to others for questions and just things that you've done and things which you'd like to do in the future. But Brian first.
Yeah, just one quick thing. I just think it's really cool and interesting that, Jodi, when you're, with the research talking about the 2015 and 2016 data, you mentioned, when you were just using like really comparing to that radiometer data from SMAP when you're getting like that 40-kilometer resolution where the students weren't getting a really great match between the ground-based data and the SMAP data. And then when you saw the 2017 and 2018 data, you were getting a really good match. And that's when 2017 was the time when the Sentinel-1 data was actually released to the public, on Worldview, where we were getting that combined 3-kilometer, almost sometimes down to 1-kilometer resolution, where we're seeing that better match. So I just think that is a really good case study showing that, that 40-kilometer where it was really hard to compare, where you're getting that huge, that really, not that great, spatial resolution. And then with that combined data, that you're actually seeing that in the data directly, which is just really cool to see. And, and then that the students just dove deeper and deeper and deeper and then saw that, within their data. Very cool.
Thanks, Brian. Open it up to everybody else. Questions or tell us about what you've done with NASA missions and globe protocols.
I have a couple little question comments, and I apologize for coming late, so shut me up if this is not a good. I loved when you said that the students were seeing surface temperature as a driver. I thought that we always want to know what the driver is, and it seems like an important sort of teachable moment to think about systems and how like things drive each other, right? It's not like there's a single driver and it goes from point A to B, right, to point D. It's all interactive. And I've just been thinking a lot about how difficult it is to teach systems concepts, and that this is like a really beautiful approach to doing that. This is such great work. So thank you. And the other thing is when you talk about climate and their projections and seeing that Ohio would look like Texas a few years from now, it just reminded me of Katie Spellman's presentation at the last annual meeting when we were together in Fredonia, and she had done this project related to looking at data a latitude lower, and that becomes like a predictive approach, right? Because if our theory of action is that it's going to get progressively warmer. And I was just wondering if anybody had ever done anything like that, or whether your students had attempted to like look at what things might look like. Where would you be? Like Kansas would be like 1 below Ohio or something like that, right? Oh, well, this is what it's going to be like in 15 years, right? Is look at the Kansas data. Anyway, I just think this is just such great work, and it seems like your students had such a rich experience.
Svetlana, that's interesting that you said that, because that year the students who were really into this climate prediction piece, they put into their presentation, because they had to present to people on campus at the end in May every year, and they put on that the Ohio buckeye tree is going to be the Michigan buckeye tree. And that is like, Ohio and Michigan, we're like rivals, right? And so no one takes away the Ohio buckeye tree, and let alone Michigan, right? So right. I thought that was really interesting, because they were trying to show that, things are moving, and that the buckeye tree won't be able to tolerate the climate in Ohio next century.
Yeah.
With the high emissions scenario.
Yeah, yeah. That's a great concrete way to put it.
Any other observations, ideas about deepening connections between the active missions and globe protocols?
Well, I always have ideas. One of the things that, I was thinking about when we were putting this presentation together is that how much I personally learned, right? Which then makes me better at helping others with Globe, how much I learned from Brian and the team from this. And I was thinking that, moving forward, this is what partners need. We need to learn about these missions. We
Mhm.
need somebody that understands the mission to help us learn about the mission. Like I can read about it, but it's not the same.
Yeah.
Being with Brian and taking it, tackling it throughout the whole year, we just come back and ask questions and make sense of it and learn more and then learn about, what's happening with the active radar, what happened with it and how they're going to correct it. I mean, that just helped us all get better. So I would think that moving into the future, having whether they be water coolers or what kind of sessions we can have, but just having some real talk about these satellite missions is going to make us better at what we do.
Get the right SMEs involved and everything too,
Yes.
who are sustained, not just like a once a presentation and then you don't see them forever, the right.
Exactly.
Yeah.
I love that. And like documenting, you've made like kind of a brief comment about how learning rich it was for you, but I think documenting that and the kinds of things that you are able to learn by interacting with Brian that you can't learn when you're sitting at the university, I think is really instructive to others because we're always trying to get SMEs in. Teachers don't, they kind of get in general, or why having a career talk would be a good idea, but that is actually not the most rich part, I think. I mean, it's useful, right? But it's that essential learning together that is so powerful. And um, yeah, I think you could do a whole paper just on that that could be really useful to people. I would love to collaborate with you on that something, Jodi.
Yeah, I mean it's true. So I had a joint appointment at Bowling Green. I was in the College of Education, and then I was there for 25 years. So about 10 years into my career, there was this position in environmental education that I used to be on the board or something for this committee, and so they said, "Hey, you should apply for it." So then I was also in the College of Arts and Sciences, and I had to live in both worlds and actually go up through my second promotion in both colleges. That's hard to juggle. And oftentimes educators don't get a lot of respect from arts and sciences, to be honest. But Globe put me in a position that they thought I knew my stuff, whether I did or not. I hope I did. But I was teaching science classes. All of a sudden, they're like, "Oh yeah, you can teach this earth science class because you know what you're doing because we just saw your kids' research, right?" So
Mm,
it gave me some this level of respect, and again, I'm going to put that back on Globe. Taught me a lot of this, and then working with Globe scientists along the way, I just got better at what I did. And so I think that there is some just really research could be done on that, but really there's just a lot to be said for what happens to the individual, to the partners, Globe
mm,
partners, when we collaborate.
exactly. Mhm. Actually, I was just telling a story yesterday about supervision of students in work-based learning, which is when kids are working with scientists or employers or something, is that some of the best professional development, the faculty were saying that some of the best professional development I get is when I'm overseeing what the kids are doing by interacting with the employers or the professional, right? Is that because then you can find out what's current in the field and so forth and the latest instruments and yeah. Anyway.
Oops, there's some chat stuff I should probably look at. Stop this share.
Has anybody checked out the one pagers on the NASA page? I put a link in there. And I don't know if there's other ones as well, but these one pagers can be super helpful, especially as we go forward.
Are these all of them, Jen? Would you say is this the whole
Uh,
list of what's active right now?
I I don't know. No, there's more.
Because the lake yeah,
Hmm.
that's cool.
I mean, I was just trying, we have been kind of watching to see what has been happening with the missions, and especially with the potential cancellation and things like that. So we've been trying to figure out where the best places to go are for information on some of these missions, just so for our reference. So I know that this site came up. There are other ones. I don't
That's
know
cool.
if Brian has other
Yeah,
ones.
yeah. I just popped a site in there that's interesting too. It's Earth Science at Work. It was a site. I think it originated at the original one started at Goddard, since that's a probably like one of the biggest. NASA most of the Earth science is done at Goddard. Of course, it's done other places, of course, Langley, JPL, and stuff. But I think it originated at Goddard and got spread out through. But it's a good site because it breaks things down to the Earth science missions and why we're doing them. But it breaks it off into technology, flight, research and analysis, data and modeling, Earth action. It does talk about some things. It goes to, it has a whole bunch of multimedia sections, the data, talks about, as I mentioned, it talks about why. Um, it is a U.S. Specific website, but it talks about some of the missions that we're talking about in it, and some of the articles, like, um, and I'm a little partial too because it has a section about ISAT 2 in there too. So, but yeah, but it's a good site because there's a lot of good information about it, and why we're doing it, and you know how it aligns to um, space-based and ground-based observation.
Very cool.
I was just thinking again, there's like, National Geographic has this National Geographic Explorer collaboration thing where they take some veterans with new people and put them together and then teach each other and spend a year together and do some stuff to report back out. And that'd be kind of cool too. Like if we could get the right subject matter expert from NASA, a globe partner, which we know is so critical, and then maybe some groups, whether who knows if it's schools or organizations, community groups, whoever, all together in a circle and do some pilot studies pilot programs that way of having these little circles of here's a mission, here's a SME, here's a couple partners, and here's a couple organizations. That'd be kind of cool.
And
Sign me
ecosystem.
up. I'd want to be on one.
Those are like little ecosystems, right, around each other.
Yeah.
All right, we are at the top of the hour. Have a great Thursday, everyone. Thank you to Jodi and Brian for presenting on this. Jodi is like many years of work, so it's like so cool to see the progression over time of that and how this project developed. So hopefully we'll be seeing a lot more of that in the future.